Imagine you're standing in front of your home's electrical panel, maybe during an inspection, or perhaps you're just a bit curious. It looks like, well, a tangle of wires, circuit breakers, bus bars, kind of organized chaos, right? But what if one really common, tiny looking wiring detail was actually a hidden safety hazard, like a ticking time bomb just waiting inside your walls? Today, we're taking a deep dive into something called double-tapped neutral wires. You might also hear it called double-lugging. And this isn't just some, obscure electrical term. It's a major safety defect home inspectors look for right away, and there are very good reasons why.
Absolutely. Our mission today is to really unpack this for you. We want to explore why this practice, which was surprisingly common for a while, is now a definite no-go according to electrical codes. And most importantly, we'll give you the crucial info you need to understand the risks and ensure your own home's electrical safety. We're drawing insights from a really thorough expert article, Double-Tapped Neutral Wires, a Home Inspection Defect. It includes input from pros like Brian Colwern, Joshua Willett, Tress Greenwade, and Gary Rowden. Real field experience there.
Okay, so let's get right to it. What is a double-tapped neutral wire exactly, and why should it immediately set off alarm bells?
Well, at its core, double-tapped neutral wires, or double-lugging as it's often called, happens when you find two or more neutral conductors. Technically, the code calls them grounded conductors, terminated or connected under just one single screw terminal. You see this on the neutral bus bar inside your electrical panel.
Okay, so two wires shoved into one little terminal screw meant for only one, like trying to put two shoelaces through the same tiny eyelet, maybe?
Yeah. That's a pretty good analogy, yeah.
Yeah.
It might seem like it fits for a second, but it's definitely not how it's designed. And it causes problems. The rule of thumb you often hear is one wire per hole, or one wire per terminal screw, really.
Which makes sense. One wire, one secure connection.
Exactly, because think about it. If you have multiple grounded conductors jammed under one screw, what happens when you need to work on one circuit? You loosen that screw to take out one wire.
Ah, and you've accidentally loosened the other one too. Or maybe even both.
Precisely. You've temporarily loosened all the conductors under that screw, and that creates an unstable, potentially hazardous situation right away. Loose connections are bad news.
Okay, that clicks. But, it makes me wonder, you said this was common practice once. How did something that sounds so fundamentally iffy become so widespread?
Yeah, that's the surprising part for many people. Before 2002, double-lugging neutral conductors was, well, extremely common out in the field. Lots of installers did it. But this is really key. It was never actually permitted or considered safe according to the UL 67 safety standards for electrical panels. Those UL standards have, for decades, consistently required an individual separate terminal for each branch circuit neutral conductor.
Wow, so there was this huge gap between what electricians were doing day to day and what the actual safety standards required.
A significant gap, yes. The practice outpaced the explicit rules for a while, even though the underlying safety standard was already there.
So if it was never really safe by UL standards, why the big change in 2002 with the National Electrical Code, the NEC? What finally made them step in and say, no, you absolutely cannot do this?
Good question. The 2002 NEC revision was really about removing any ambiguity. They introduced a specific section, NEC 408.41, to explicitly prohibit double-lugging neutrals. This wasn't just pulled out of thin air. It came from documented safety concerns. Field evidence was piling up, showing just how mechanically unstable these connections were.
So real-world problems were happening.
Yes, fires, equipment damage, things linked back to these connections. So while you could argue it was implicitly banned before through UL standards and general NEC rules about following manufacturer instructions, the 2002 update made it crystal clear, explicit. No more gray areas for installers or inspectors. And it really just reinforced a foundational rule that's been in the NEC forever. Section 110.3b.
What does that one say?
Basically that all electrical equipment must be installed according to its listing and the manufacturer's instructions. And since the vast majority of those neutral terminal bars weren't listed or identified by the manufacturer as being okay for more than one wire.
Double-lugging was always technically violating that rule, even if people didn't realize it or chose to ignore it.
Exactly. It was always against the equipment's own safety listing. So the 2002 code just put a finer point on it, directly addressing the neutral bar itself.
Okay, so it wasn't just some bureaucratic code change. It was based on real safety issues and existing principles. Now, let's get into the nitty-gritty, the stuff that really impacts homeowners. What are the specific dangers? Walk us through how that double tap turns into a serious threat.
Right. The dangers are very real. First off, as we've touched on, that shared connection point is just inherently mechanically unstable.
Mm.
Two wires under one screw, it's not solid. This directly leads to loose connections over time.
How? Just from sitting there?
From normal use, actually. Think about electrical loads fluctuating. You turn on the microwave, the AC kicks on, things cycle. Those wires heat up and cool down. They expand and contract. But two separate wires under one screw might do that at slightly different rates or amounts.
Ah, I see. So they kind of work against each other under the screw.
Sort of, yeah. Or one might expand more than the other. Over time, this constant tiny movement can cause one or both wires to loosen their grip under that terminal screw. And a loose connection in an electrical panel is, well, it's a recipe for disaster.
Because
Because it leads directly to overheating and arcing.
arcing, that sounds bad, like electricity jumping.
Exactly. Electricity jumping across a small gap where the connection isn't tight. This generates intense heat. We're talking serious fire risk right there inside your metal panel box. I've personally seen panels where the insulation on the wires near a double tap was visibly melted or charred from the heat and arcing. It's not theoretical.
But that's genuinely scary. Okay, fire risk is huge. What else? You mentioned maintenance issues earlier.
Right. It makes working on circuits much trickier and potentially dangerous. Let's say an electrician needs to isolate one circuit for repair. They go to loosen that one screw holding two neutral wires.
And they might unknowingly disturb the connection for the other circuit sharing that screw.
Precisely. They could inadvertently loosen or even disconnect the neutral for a totally different circuit without realizing it immediately. That can create unexpected hazards elsewhere in the house.
Okay, that adds another layer of risk. And you mentioned something specific earlier, MWBCs. What was that again?
Ah, yes, multi-wire branch circuits. MWDCs. This is where the danger gets amplified.
Remind us quickly what those are.
Sure. An MWBC is basically a wiring shortcut, but a permitted one when done right. It uses two different hot wires that share a single neutral wire to power two separate 120-volt circuits. You often find them in kitchens for counter outlets, sometimes other places.
Okay, two circuits sharing one neutral. Got it. Why is that extra dangerous with a double tap?
Because if that shared neutral connection, which might be double tapped with another neutral at the panel, becomes loose or disconnected, even for a moment, the voltage balance between those two circuits goes completely haywire.
What does that look like? Flickering lights.
Worse, you could get, say, 100 volts on one circuit and 140 volts on the other instead of the normal 120. It's called an overvoltage condition. Imagine your TV or computer suddenly getting hit with way too much voltage.
Poof. Fried electronics.
Instantly. It can destroy sensitive appliances and electronics, and again, that unstable voltage and potential arcing raises the fire risk too. It's a critical failure point for MWBCs. So you add it all up. The basic instability, the overheating, the arcing fire risk, the maintenance complications, and this specific severe risk with MWBCs. It's why every current version of the NEC and all related safety standards flat out prohibit double tapping neutrals. No ifs, ands, or buts.
It's abundantly clear why it's considered a major defect then. Given all that, how do the current codes make sure this doesn't happen now? What are inspectors actually looking for?
The current codes are very direct. The 2023 NEC, for example, has sections 110.15a and 408.41 that explicitly forbid double-lugging neutrals. The core principle is simple. Individual terminals for each neutral wire, period. NEC 408.41 puts it plainly. Each grounded conductor shall terminate within the panel board in an individual terminal that is not also used for another conductor. Can get much clearer than that.
No wiggle room there.
None. And 110.14a adds another layer. It says terminals designed for more than one wire have to be specifically identified for that purpose by the manufacturer. And the vast majority of standard neutral bus bar terminals, they're just not identified for multiple wires. They're designed for one.
So unless the terminal itself explicitly says, okay, for 2 wires, you can only put 1.
That's the rule. And even the residential code, the IRC, International Residential Code, in the 2024 version under E376.4 echoes this. Individual terminals are the requirement, with very limited exceptions for specific parallel setups, and only if the terminal is clearly marked for it.
Okay, so bottom line. Seeing 2 neutral wires under 1 screw is a definite code violation today. It needs fixing. Now, let's shift to the practical side for a homeowner. If a home inspector flags this, finds double tap neutrals in your panel, what's the next step? What do?
First thing, don't panic, but do take it seriously. This condition absolutely needs correction. And crucially, this correction must be done by a qualified, licensed electrical contractor.
Right. This is not a DIY weekend project. Working inside an electrical panel is dangerous.
Extremely dangerous if you don't know exactly what you're doing. High voltage, risk of shock, potential to make things worse. Call a pro.
So what does that professional fix usually look like? Is it a huge, expensive job?
It depends on the panel and the extent of the issue, but often it's manageable. The most common solution is for the electrician to install an additional neutral bus bar strip inside the panel. This gives you more individual screw terminals to land those extra wires properly.
So adding more parking spots for the neutral wires.
Exactly. Sometimes, if there's enough space on the existing bar, they might just be able to rearrange things. Or, in some cases, they might use specific terminals that are listed for 2 wires, if appropriate and available. But usually it involves adding more terminal points. The key is that every single neutral conductor ends up with its own dedicated secure termination point. And of course, all the work has to meet the current NEC standards and any local code requirements.
It sounds like a necessary investment in safety, not just a cosmetic fix.
Absolutely. It's correcting a known fire and electrical hazard.
So bringing this all together, what's the big message for you, the homeowner listening right now? Understanding these sometimes seemingly small details about your home's electrical system is actually incredibly important. It's about protecting your property, sure, but more importantly, protecting the people inside. This whole deep dive really drives home why getting regular professional electrical inspections can be so valuable, doesn't it?
It really does,
Right.
especially in older homes. These inspections help catch these legacy installations, things that were maybe common once but don't meet today's safety standards. Identifying and correcting them proactively prevents potential disasters.
We've definitely seen today how something that looks minor, just 2 wires under 1 screw, can pose a very real, very tangible risk. It's a powerful reminder, I think, that building codes and safety standards aren't just static rules. They evolve. They change for good reasons.
Often, yeah, in response to real-world problems, accidents, and just a better understanding of the physics and risks involved. It's about continuous improvement in safety.
This exploration of double-tap neutrals really highlights something important. Knowledge is great, but it's most valuable when you understand it and, crucially, apply it.
Right, especially when it concerns the safety of your home and family. Critical thinking about how your home systems work and whether they're up to snuff is vital.
So as you think back on our conversation today, what's the one thing that really stands out to you? Maybe it's that hidden fire risk we talked about, or perhaps it's just the surprising fact that this unsafe practice was ever common at all. It kind of makes you wonder, doesn't it? What other legacy installations or outdated practices might be lurking, hidden away in walls or panels, just waiting for a professional eye to spot them?
That's a really potent question to leave people with. It prompts a broader thought. What other parts of your home, maybe plumbing, maybe structural, maybe insulation, might be operating under assumptions or standards that are now outdated from a safety or efficiency perspective? It's definitely something worth mulling over as you think about being proactive with your home's upkeep and, ultimately, its safety.